Hello everyone and welcome back. In today's video, we're going to be exploring how does a generator work. Now this topic is not related to any of the NCERT books or revisions that we've been doing. So this is out of syllabus, but it's just for you to know and it might be fun. To start with, we need to know what a magnet is and what is the magnetic field. Magnet is anything that has two south and north poles and has magnetic field around it. Now what's a magnetic field? Magnetic field is there are magnetic lines that go from north pole to the south pole or in a magnet. And the surface, which is the area which is covered by those lines, is the magnetic field. This picture really explains how it is, and this picture is not by me, this is by Google Images. What is the flux of a magnet? Flux is the number of magnetic lines passing perpendicularly through a surface. It is represented as phi. Phi is equal to BA Cosθ, where B is the magnetic field, A is the surface area, and theta is the angle between the surface and magnetic field. Its unit is Webers, and the unit of magnetic field is Tesla. Structure of a generator. If the magnetic field changes near a coil of copper wire or any other wire, then the electrons in the wire start to flow, and you know that the flow of current is the same as flow as electron. Thus, electricity is generated. If you connect a bulb with the wire, then it will light up if there's enough electricity generated. Here in this picture, we have got a galvanometer which measures how much current is passing through the coil of wire. Now this picture is also not by me. Any of the pictures are not by me. Faraday's law of induction. Faraday's law states that the electricity generated is proportional to the rate of change of magnetic flux. Let me explain this. If we turn the turbine faster, the turbine is it's literally like the magnet spinning. So the magnetic field is changing near a coil of wire, so that's the turbine. If we turn the turbine faster, then the magnetic flux will change faster. And so the electricity generated is more, right? So this explains that the rate of the change in the magnetic flux is proportional to the electricity generated. Now there's the Fleming's right-hand rule. Fleming's right-hand rule states that if you structure your right hand like this picture right here, where the thumb, the forefinger, and the middle finger are at the right angle to each other, then your thumb will be pointing towards the direction of force, the index finger will be pointing towards the direction of the magnetic field, and the middle finger will be pointing towards the direction of induced current. Now I did the experiment as well. This is how my experiment looks like. This is the only picture which is by me. It contains neodymium magnets, coiled copper wire over plastic bottle container, and connected LED, which is 3 volts. Now these neodymium magnets were meant to be shaked in this container. So when they shake, the magnetic field changes near this coil of wire, and so electricity flows, and thus this LED will light up. That's it for me today. Hope you enjoyed. Hope you learned something new. Very easy to understand. And Fleming's right-hand rule is just to tell which way everything's going. Faraday's law of induction is that when you change the magnetic field quicker, or the magnetic flux quicker, then the electricity will be generated more. And a structure of a generator is the basic thing that you need to know. The flux of the magnet is just the magnetic lines magnetic field lines passing perpendicularly through a surface. And that's all. Hope you enjoyed. Hope you learned something new. This was just a short summary at the end. And till then, take care and bye bye. I'll come with you with a new video and bye.